gang, let's try doubling time. So you'll be either asked to do find the time for half-life or find the time for double time for the bacteria or whatever they're giving you to double. So it's similar, somewhat similar to before. So let's say that your initial quantity is 10 again. Let's say initial quantity is 10. You have 10 bacteria. So the time for it to double means that you have to double your initial quantity. So for me to double 10, I'd have to now be at 20, because that would be doubling 10. All right, but in the word problem, they're going to again say that the initial amount is y sub 0. So if you start with y sub 0, what would doubling y sub 0 look like? Okay, hopefully you see that it would be 2y sub 0. It would be twice whatever y sub 0 is. So if y sub 0 is 10, 2 times 10 would be 20. It's that kind of concept, okay? So we're going to do that again. So how many hours would it take? T is in hours in this problem for the bacteria to double. So we're starting with a generic amount of y sub 0. You'll notice that this value is positive, which means it's growth. If this value is negative, it's decay. So the last one we had, this value of b was negative, right? So this is going to grow. This is exponential growth. I want this to be 2 times y sub 0, so 2 times the initial amount. And then if you recall from the last video, whenever you solve an exponential, the very first step is to make sure it's isolated. So right here we have a product, and you can't have a product before you start to apply the log. So you have to take this off. Okay, so I'm going to divide it off. So y sub 0 divided by y sub 0 is 2. Okay, that would have been, and again, they're not giving you a specific amount, but if they had, it would have been the same comment, right? If you started with 10, and you wanted to make 20, the first step would be the same. I just think it's a little easier to see with exact values. It would be the same concept here. You would get rid of this, and you'd say 2 equals, right, and you get that. All right, gang, so we're now going to solve for t. So to solve for t, we're going to take the ln of both sides. Property number 3 allows us to bring the exponent down in front. Okay, and as we just said before in the previous video, ln of e equals 1. All right, now we're almost there. We just got to solve for t. So to solve for t, you have to take, so right now this is being multiplied by 0.058, right? So to isolate t, you have to undo that. So you have to divide that off. So t is going to equal to ln of 2 over 0.058. Now, they again want this approximated to the nearest tenth. The tenth is the first decimal on the right side. So to estimate to the tenth, you have to go to the hundredth. All right, let me just make sure you guys can see this. So ln of 2, close. Remember, we talked about this in the last video. You have to close the ln. Divided by 0.058. Okay, I'm going to hit equal. All right, now my brain's going to go over to the hundredth place. So we have to round to this, which means we have to go to this. So if we go to this, this is going to round this up. But this is already a 9, which means it's going to do what here? So if we're going to this place to round, but this is a 5, which means we're going to round up. This is already a 9. So that means that this is going to have to equal to 12.0. And again, Alex didn't give a unit, and so I didn't give a unit, but it would be bacteria. So we would say 12 bacteria. If you're going to look at like individual items, like it would be more common to, I mean, depending on how exact you want your answer to be, like if you have 11.8, you haven't quite made it to the 12th, so, you know, you probably say 11, but, you know, it just depends how they want you to round it. So in this case to the 10th, so we'll say that it's 12. Okay, gang. That's it for the two varieties on number 5. I'll catch you. Bye-bye.